All right, you guys, the event loop or the main loop or the loop or the Node.js loop or the libuv loop, whatever you want to call it, there is a loop in Node.js. And in this particular lecture, we're going to talk about why do we have a loop to begin with. And we're going to talk about an abstracted level overview. Just that in this particular lecture. Because I like to go, top down approach with my teachings. And this is actually a good example where you cannot dive deep without understanding kind of why do we need things to begin with, right? So let's dive into this lecture. So Node.js execution. Node is a C++ program, right? As we talked about it. It takes an input, and that input happens to be a JavaScript file that is later interpreted by the V8 engine, which is linked with the Node executable, as we talked about. And it just reads and interprets this, execute this line by line. That's what it does. So if I have an input that's JavaScript and I execute it one by one, and I just follow the functions. There's a function call. I jump to the position that I want to execute, and I just execute this code one by one. And then I end my execution. And if there is nothing left in this JavaScript file, I quit. And I terminate the program. The program exit. It returns either 0 or 1. And the operating system just yanks it. But there are situations, my friends, where the program doesn't really end there. JavaScript does more stuff. Example is timers. We can't really end the program if there is a timer that needs to be executed after 5 minutes, right? We need to keep the program running. And how do you keep the program running? What does that mean, right? You need to do something meanwhile, right? You need to wait. File IO is another example. I'm reading something, but the disk is taking a long time. When I say a long time, I'm talking milliseconds, and SSD is a little bit less, right? And when that time comes back, I need the operating system to tell me that, hey, this is ready. Here's your content you asked for. I read this file, and here it is. And that's when I need to execute a bunch of other code based on the event. Event, it's a new word I just threw there. That something happened. I read this file and something happened. I finished reading this file. I want to execute another code. So it's based on some external event. So it's not linear code anymore. So really, again, we need to wait. While I'm reading, I send that read. It's not my job anymore. The OS is doing the read via epoll, or not really, via read system call, right? Epolls for network, mostly, right? And then I'm just here doing nothing. So I cannot quit. I cannot exit the program. So I need to loop and wait. Another reason why we need a loop. And then another third option is network. Hey, I'm listening in this port and I'm just here. I cannot terminate Node because maybe someone will connect to me right now, right? So you just need to wait. So most of the thing that we're doing is just waiting for stuff to happen until we no longer want to wait. And we're going to define what that means, right, in this course. When does Node absolutely okay for Node to quit, to exit, all right? And that's when things get really interesting. So network IO, reading from a connection, writing to a connection. Reading from socket is one of the interesting things. Like reading from file is predictable, right? I'm reading and after a few milliseconds, I'm going to get a result, right? I know it's there. I'm reading a file. But reading from a socket connection is different because you have no idea when the client will send actually something through the socket. I have absolutely no idea. It could come at any second. So you have to keep listening and waiting. And it's really the kernel's job, not the Node executable, but the kernel, once it happens, it will notify us, and then that's where Node has to be there and ready to pick it up. So we need to loop. That's why serial execution doesn't work anymore. We need to come back and check and check and check and check. And that's where we have the event loop. Meet the event loop. It's an event, a bunch of things happening. IO is happening, stuff happening. So we need to keep looping literally until there is no work for us to do, right? Timers, network IO, file IO, things like that I need to do. I need to continue my loop. And now I'm gonna talk about a loop. There are phases in this loop, and I'm gonna oversimplify it in this lecture. And in the coming 6 or 7 lectures, we're gonna dissect every phase. Every phase, you guys, every phase. So yeah, so this loop has a bunch of phases. And each phase, guess what? We do something in each phase, and we queue a bunch of callbacks. That's another new word we just invented. Callback. Call back. So callback is a function, a piece of code in JavaScript that is getting triggered after a specific event is satisfied. I.e., I read from a file, here is a callback. I'm reading from a socket, here is a callback. If the listening event happens successfully, here is a callback that you want you to execute. Who's going to execute? The operating system will tell Node, and Node will wire the callback, wire it literally, to this event. And an event is really something that happens in an instance of time, right? If a connection is coming, if a connection is new connection coming, it's another event. We wanted to wire this callback to this event, and it's optional. You can wire, you cannot wire a callback. And that's when I'm executing a timer. After 3 seconds, please go and run this callback. And that's just, so you just have a bunch of phases. Each phase has a queue of callback because one callback might have been scheduled after the other. So it's a queue. Queue is an array of callbacks. And then just like pick one, whoever FIFO, first in, first out, kind of a situation. Just pick it up and then execute. And then when do we terminate? When there is absolutely no callbacks left, or there is nothing to do as well. Like, and kind of no callbacks determine that there is nothing to do, technically. Because like if you have a timer, there must be a callback associated with that timer. If there is no timer, then, well, we're done. If there is no connection, if you closed all the connection to all clients, then there is nothing to listen on. There is nothing to read from, right? And as a result, we just, hey, I'm not reading anymore. I'm not polling anything anymore. So that's very important. So let's go through a simplified version of this. It literally looks something like that. You execute some event. I'm reading a file. I'm about to do a timer, and then you do a callback. You queue a callback as a result. Sometimes I execute a timer callback, and then that execution triggers another timer after 5 milliseconds, and then maybe a read from a file, and it triggers another callback from a socket. And all of these will have some execution, actual reading from file, actual reading from disk, actual reading from network. And they, after this happens, will register these callbacks. And they will, what we do is just pick one callback from the queue, execute it. And that's it. It's just like that. So and there is one thing that is an exception, is the initial code execution. That there's no loop yet. We're just executing the code in the beginning, and then we initialize the loop. Very important to understand that. We're gonna go through that in details. But the initial code execution, like when I first execute the code, I can register some callback. I'm using the word register here. Registering a callback is different than executing the callback, right? So watch out for that. Like if I say set timeout and call this callback, I'm registering the callback right now, but the callback will not be executed until 5 seconds later. Make sense? I'm registering a callback to read a file and tell me when the file is read and call this function. I'm registering a callback right now, right? The moment of execution. The execution of the read file might happen later in the call phase, in another phase. And the callback might even happen even later than that. The actual execution of the read file happened, and then maybe a few milliseconds later, because the disk is slow, that happens, the callback will be actually executed, right? So you gotta understand all of this stuff. And then we have a bunch of queues of callback. What about promises and async await? Those are also callbacks. They're just syntax. We're gonna show about that in the promise lecture. I promise. Okay. The best thing really to go through this is to go through an example, I think. And I'm gonna disappear here so I can show you the entire screen over here, you guys. But let's go through this code a little bit, and then we're gonna. So this code is doing a bunch of stuff, right? And take it with a grain of salt because we're gonna go into details in the upcoming lectures. But here's the code. We're importing the FS library because we're gonna read from the file from disk. So we need the FS library or the module. We have x equal 1, y equal 2, z equal x plus y. We have a timer callback that just prints something here. We have a timer 2 callback which happens to read from C text and then calls another callback called read file C callback, which is here. That function prints read C after 1 second. After a second. And then we have a function called write file B callback that prints and then calls another timer. So it's a chain of a chain of a chain of a chain. And now I did it on purpose to kind of show you all of this stuff. And we're going to dissect all of this right now. Okay. Set timeout, timer 2 callback after a second, right? Which execute timer 2. And then we have read file IO, which prints and then write a file. Then after it's writing successfully test to the B, we call back write B callback. And I did it for this reason, so you can clearly see the sequence of events. And then we have read file A, and then after the file is read, you call back read file A, which we have defined. Where did we find read file A? There it is, right? And then we set a timer. So when we actually execute the code, what happens is this is the initial piece, is these three guys. That's it. There is some code that happened here, but let's ignore it for now. In the initial phase, before even the loop starts or anything like that, we execute x equal 1, put in the stack, y equal 2, and z equal x plus 1. That's the execution that happens right there and there. No callbacks yet. 0 callback. I go here. I go next. There's nothing to do here, just a function. I'm not gonna call it. It's just a registration of the function. All right, sure. Function. Nothing. I'm not calling this function. I'm just going for them and marking them. Nothing to execute. Here, I have to do something here. Here, I'm reading a file. Now, are we actually reading the file here? Unknown for now. We'll come to that. Technically, in the initial phase, we're not reading any file. We're opening the file. But we'll go through this file system. When we go to the file phase, when we understand file, we're going to go into this is the second section. The internal section. Now we're in the loop. So don't worry about when the reading actually happens. But that is, guys, I swear to God, this is so important, right? Like, I'm executing a code. When the execution happens is so critical. I swear, it's so critical when the actual file is being read. And we're gonna come to that. We're gonna do an S-trace. We'll show you the guts of how things work. We'll see exactly when the call to read file went from node to the operating system. And it's critical to know when, because that's where the delays happen, right? So keep that in mind. Back to this. I'm about to execute this. Let's say, hey, just register a callback. Read and register. So we're doing the read file here, and then we register the callback, say, hey, read file A callback. Am I going to execute this? No, not yet, because the read file didn't happen. So we're just registering a callback. Next, I'm registering a timeout. Again, we're still in the initial phase. Register timer 1 callback. Boom, put it here. That's it. Move on. Now, we're picking up a callback. Now pick up, what is the callback? Because we ran out of code. There is no more code. Right, guys? There's no more code. There is no more code. We just ran out of code. We finished all the code technically. Now, what we do, if we run out of code, then what do? We pick up something from the callback. So what do we pick up? Now it depends really which came first. We're assuming that read happened before the timer here. Okay, but it's not always the case, right? In this particular case, but let's say the read file actually happened before the timer 1 has executed, right? The 1 millisecond one, or maybe we have the file cached. Maybe we executed very fast and we did that right before that. So now we picked the read file and now we're executing the callback. So what we did here is actually we read the file successfully and then we invoked the read file callback. Now we're ready. I'm just going through this stuff, executing now. Now it's a new execution. Execute console read A. Now we're running into another kind of IO. Read this and register a brand new callback called write file B callback, and then just put it in the back of your pocket and then just go there. Right? Whenever we execute it. Just put it there. We move next. What's the next? We done with the read file. Now we pick up the next callback. Happen to be timer 1 callback. Pick it up. What does it have? Oh, it's just a print. Okay, let's print it. Right? When we executed that, printed the console.log. Boom. What's next? We pick up another callback from the queue. Execute that guy. And then write, hey, another registration of a callback. Happened to be after 1,000 milliseconds. Timer 2 callback. Let's register it. Write file B has done. What do? Well, pick up the timer 2 callback. And you see the pattern, you guys? Pick up, execute. Pick up, execute. Pick up, execute. This is the loop. In its primitive form. It's a very simplified form. And you're going to have a lot of questions, you guys. It's okay. Hold those questions because we're going to answer all of them, right? As we move through the course. Give this lecture a little bit of time to marinate. It's going to become clear as you move on, right? But yeah, feel free to shoot these questions. It's fine, of course, right? But they're going to become clear as you move on. But yeah, I'm just moving on, right? All right, I'm executing this. Read file. All right, read file. I'm reading the C. Register another callback. Read file C. Boom. All right. Now, after a second, because that's the timer, right? Remember that we registered in the right. After a second, now timer 2 has popped. Now we're executing timer 2 callback. Executing timer 2 callback, which happens to do a read, registering a new callback, read file C. And then after a while, read file C is now, we finish the code. Now we pick up read file C, execute that, and then print C, and all the queues are empty. That's the final output. This is what we get. So we went through that, and this is exactly what the output is. So we got read a.text, then followed by timeout elapse 1 millisecond, read file A, and register the write, but then the timer kicked in before us, executed that, we wrote B, and then we finally read C after 1 second. And that's it, we're done. All right, so that was like a quick overview of how the event loop kind of works. And I had to add this lecture to give you like a taste of the overview of the architecture of the event loop. Why do we need it? And how does it look like from a bird's eye view, if you will? You know, so Node is a program that takes an input. The input happened to be a JavaScript file. We just execute it linearly. But then Node comes with this thing that's called the event loop. That's just we keep looping, and then we register callbacks, which has the callbacks have ability to register more callbacks, and the callbacks register more callbacks until we basically run out of callbacks, right? And then we exit the program. So let's go and do some exercises. And okay, this is gonna be the pattern in this course, right? We're gonna do a lecture, some PowerPoint slides, we're gonna explain them diagrams, and then we're gonna go to the code, right? And then in the code, make sure to pull this repo, right? I'm gonna add it as a zip file just in case. In the earlier sections, you can download that, or you can just go to the repo. And so yeah, you can have that repo clone, and we can follow the exercises. Let's go. You can go to the GitHub repo and download this. It's gonna be in the description of this lecture and the earlier lectures. And you just go and clone this entire repo. It has like around 28 sections. I had them labeled with the 0001, and we are currently in the event loop. This is the example. So this is the V8 example that we went through, right? This is where the stack goes. This is an example of an object. This is an example of an array, right? And here's our example. So let's go ahead and execute this code, right? So I'm going to use Visual Studio Code for this. You can use your favorite editor for this. So here's the GitHub repo for this. You can just take that link and do a git clone, and you can have access to that. I'm going to have this linked here, github.com, hnasser, node course content. This is how you get it, okay? All right, guys. So let's go ahead and run this particular code. 001 event loop, multiple examples. So make sure you are at the root node course content, because the files that we're writing and reading to are actually here. They live here. So we're going to do node 00. That's how you do it basically. 001, and then run that example. And you can see that we get read a.text. We read the file, has test in it. The callback was executed. We didn't get an error. We get read, we schedule a write, but the timer was faster before the write, and we printed the timer next, and then write, and then read C. So I'm going to execute this same script, and I want you to notice something. We got lucky, read before the timeout, but look at that. Timer before the read. We are at the mercy of the operating system in this particular case, because timers work with really the sleep function. We're using libuv to put the timer to sleep and then wakes us up after 1 millisecond, versus the read, which is at the mercy of the file system read cache, the disk cache, and then the actual disk, my disk, right? So you will run this and you might see the timer before the read. And sometimes you're going to see one before the other because it's not consistent, just a race condition, really whoever wins. I mean, if you change this to 100 millisecond, then you're consistent, right? Change this to 100, let's change it to 100. Yeah, the timer will always come, almost always come after, right? Even after the write, because it's so slow, right? You've seen it, the timer was pushed, right? But if it's 1 millisecond or 0, then you don't get that consistency. All right, let's jump to the next lecture.